All right, good morning. Let's get going so I get everybody back on time for lunch. So my name is Philip Floy. I'm the field CTO at Rubrik X. Rubrik X is a, let's say, innovation and acquisition team within Rubrik. So I'm also going to talk a little bit about one of the latest acquisitions that we made, which sort of fits nicely into our data security strategy as a whole. But I'll link it back to what we're doing for VMware specifically, obviously. So if you look at Rubrik, we've been doing this for a while now. So the company turned 10 years a couple of months ago. So we were founded in 2014, and in 2014 we built a product that we brought to market, which only had one feature essentially. So we could back up and restore VMware environments, and we could write archive data, so let's say longer-term retention data of VMware environment into an AWS S3 bucket. That's the only capability we had at the time. And even though that was the only capability, we were pretty successful selling that actually. VMware or vSphere is still our biggest workload to date. So most of our customers are VMware customers. Obviously, we had to expand our workload capabilities over time. So we added other hypervisors, we added physical workloads, more and more cloud workloads, obviously SaaS workloads, and so on. But next to our, let's say, basic data management capabilities, i.e. backup and recovery, we added a bunch of data security capabilities as well. Reason we did that is in 2017, we had our first customer reach out to Rubrik support saying they were ransomed. So they had a backup on Rubrik. The company was called Lang's Building Supply. It's a public reference on the website as well, so you can check that out. But the thing was they were ransomed, so their production environment was encrypted. They had backup data on Rubrik, but they weren't really sure how to recover that data quickly. And especially there was some concern around, if we restore data, do we know we're not going to reinfect our production network? So there's really no easy way to sort of understand when did this piece of malware enter the network, when was it activated, what was impacted from a ransomware activity perspective, like which VMs were targeted, which workloads were encrypted, and so on. So that was a bit tricky, so we had to manually sort of walk them through that process and help them with that, which all worked out fine. So they were restored in a pretty short time back into production. But of course, that sort of expanded to the rest of, let's say, the industry, and we saw a lot more ransomware activity since 2017, 2018, and then especially this wave kicked off 2020, where ransomware is sort of in the news a couple of times a day these days. So to sort of counterbalance that, we added a bunch of data security capabilities on top of having a backup copy. The core of those data security capabilities is still rooted in the fact that we have an immutable file system. So initially what we built in 2014 to store data on was our own file system called Atlas. It's still sort of the core of the on-premises CDM appliance-based capabilities that we have. The idea of this immutable file system is you create a backup of, let's say, your VMware environment, your vSphere virtual machines. You put them on that immutable file system, and the guarantee is that the data will still be there in a non-changed manner if you want to restore it. How can we guarantee that? So a property of the file system is simply that you can write to it or you can write to it once and read from it many times, but you can't overwrite data, essentially. The only way to get rid of data on that file system is if you expire the data through an SLA policy. Now, expiring that data through an SLA policy could be an attack vector, right? So if you think about a backup solution today and somebody has admin permissions, logs into your backup environment and says, actually, I'm going to change the retention of all of your backups to 1 day. And then tomorrow, all of your retention data is lost and you can't restore. That could be an attack vector. And it is something that ransomware actors are actually pursuing as well. So what we are doing to sort of counteract that is we have this concept of quorum authorization or 4 eyes policy, where wherever you want to change something that can have a material effect on data in the system, you need at least 2 administrators to agree that this is a good idea. So if you log in and you want to change an SLA policy, that will affect your retention. One of the other administrators in your environment will get an email, and he or she will have to actually approve and agree with you that that's a good idea. Having said that, we added things like ransomware monitoring in the environment. So because we have a copy of the data anyway, it's very easy for us out of band, meaning without having to take away performance of your production workloads, validate if we can find any anomalies in that backup data. So each and every new backup we make, we compare that with the previous one, and we can look at things like file changes, for example. So how many new files did you create? How many did you modify? How many did you delete? Are these new files more random than the previous version? So those sort of things taken together give us a good understanding of there's a potential encryption event or encryption impact on that system, and that will then allow us to pinpoint any anomalous activity. We've greatly expanded that to include things like sensitive data discovery, so giving you the understanding of what PII information, for example, is in that data set. So if anything is impacted, you have a good idea of what it actually looks like from an organizational perspective. Threat hunting, so the capability of saying there's a piece of malware that got into our network that led to a ransomware event. Maybe you are part of an organizational, let's say, network with peers in your network. Maybe you're a bank and you can exchange information with other banks. One of your peer banks has found indicators of compromise pointing to a specific strain of ransomware that's active in Belgium, for example. You put that into the system, we'll perform a threat hunt, and we'll figure out if you have been impacted in your network as well before that ransom event sort of kicks off. So that was all fine and well. So we figured out a way to protect all of our customers against what we today call ransomware 1.0, so the data encryption capabilities of ransomware. But of course, these ransomware actors, they sort of evolved as well, and they're now talking about, or mostly targeting, data exfiltration. So what they'll do is they'll sit in your network, look for sensitive information, exfiltrate it first, then encrypt all of your data, and now they have two shots at getting you to pay the ransom, essentially. And since most people are more afraid of PII information leaking, being put on the dark web, the chances of getting a payout are slightly higher if you do an exfiltration event. So we started focusing on that as well. So we saw this second wave in 2022 of data exfiltration from a ransomware perspective, and we didn't really have a good answer there. So the idea is, okay, you have a backup, an immutable backup of your data. If there's data destruction, i.e. encryption, we can restore it back, not a big deal. But if data is exfiltrated, it's gone, right? So once the genie is out of the bottle, it's sort of game over, and a backup, even a backup on the Rubrik, won't do you any good. So the only way to sort of provide a solution or a counterweight against that is to look at preventative measures. So what we're doing now is we've expanded our data security capabilities into posture management, where we'll figure out before the exfiltration or before the encryption event takes place, how secure is your data landscape, and can we minimize the data attack surface? So that's the whole goal of this new capability. So I wanted to quickly show you that in a demo as well. So just to sort of reiterate, we will assume as, let's say, security professionals that an incident is sort of unavoidable. So there will always be a case of somebody getting weak, leaked, or stolen passwords, being able to log into your environment, having access to accounts. People paste API keys in things like Pastebin and GitHub without thinking too much about it. So there's always going to be this concept of people gaining access to your network and to your environment. So the whole goal is then, if they have access, let's say they're able to move laterally through the network, get some better credentials, able to destroy your data or able to exfiltrate your data, what do we do about it? So for data destruction, we have cyber recovery capabilities, but for data exfiltration, we need this sort of posture capability. So that's the first thing I sort of want to show you. So the posture capabilities in the platform, they look like this. So the, let's say, dark green boxes here, they're all pre-breach. So the way that we look at this sort of logical, theoretical attack kill chain or timeline is before the exfiltration event happens or before the encryption event happens, we can look at things like data hygiene. Do you actually need this sensitive information in that virtual machine or that cloud workload? Who has access to that data? What type of permissions do they have? Do they really need admin permissions on your full database, or can they survive in their day-to-day job with read permissions on a specific column and table, etc.? So understanding that allows you to sort of right size and put in place this concept of least privilege for identity mapped out to your data assets. How secure is the data that you're storing on-prem, in the cloud, in SaaS? So think about data security capabilities in your VMware environment and how they're different from, let's say, an Azure environment or an AWS environment or a GCP environment. They all have capabilities, but they're all targeted to their own environment only. So the idea is, how do I then implement a sort of baseline security posture across all of these environments if I'm not equipped with, maybe you have 10 VMware engineers, do you have also 10 Azure engineers and 10 AWS engineers, etc. So that makes it kind of hard to standardize. So by putting that in a single policy and implementing that across all of those clouds, letting us do the translation between the policy and the actual implementation will sort of help you a lot with that. Understanding the blast radius, so how can we map users, groups, identities, roles to the data exposure on the backend and sort of minimize that. And then the final piece really is, it's 2024, so we need to do AI at some point. We have this capability to do data security anomaly detection, or data detection and response, as it's commonly known these days. So how can we monitor data activity in your environment, start to understand how that maps to expected and normal day-to-day behavior, meaning, let's say you have an engineering group, they log into your environment, and they typically, consume or interact with 1,000 records out of a backend database. That will sort of start to form a baseline of expected data activity. How can we use that to evaluate each subsequent request? So if somebody new logs into the system and all of a sudden pulls 1 million records out of that same database, that's probably an anomaly. So those types of events will start to respond to. So let me start by showing you the sort of pre-breach capabilities, and then I'll jump into the post-breach capabilities. So this is our Rubrik DSPM, or Data Security Posture Management solution. As mentioned, it's based on an acquisition. We're sort of integrating it into the larger Rubrik Security Cloud, as our solution is called these days. So the way it works is, this system has the ability to, from a marketing perspective, we call it DSPM Anywhere. So it works on-prem, it works in the cloud, and it works in SaaS environments. So specifically what it does is you connect it to the environments that you want us to start to monitor. So you add in your accounts, let's say, and then once those accounts are added in, we'll start to automatically detect data assets. So a data asset is, for example, an S3 bucket or an Azure Blob Storage location. And in those data assets, you have potentially sensitive data. So once we have identified the data assets, which you'll see here, so these are all of the data assets that we found, SharePoint environments, OneDrive, Google Drives, et cetera, we'll start to automatically classify there's any sensitive data in there. This also works for on-prem environments, right? So if you say, I'm already backing up data with Rubrik, potentially on a virtual machine, we'll identify that virtual machine. So for example, here we have a developer VM that's running a Linux file set. And this is all of the sensitive data that's on that developer VM. Then we'll provide some additional context around it as well. So with data classification, what you typically do is you look for sensitive data keywords and so on, and you try to match those using regular expressions. That's fairly interesting, but it doesn't really map to what the data is actually about. So if we find PII information like an email address, for example, well, who does that email address belong to? Is this actually a customer? Is it an employee? Is it an HR record? So what we'll do is we'll look at additional context by scanning paragraphs above and below and trying to match these things into something that makes more sense. And then you can apply policies based on data context instead of just looking at sensitive data types. So in this case, we have this developer virtual machine. We'll perform a risk assessment. So what we'll try to get you as an outcome is, how do I understand how exposed I am from this data asset perspective, and how do I minimize an attack surface in case somebody logs into your environment? The incident will still happen, that's sort of the assumption. If they exfiltrate data out of this developer VM, how can I make sure that the impact is minimized? Like it is almost zero consequence to you because there's no PII information there, or there's no HIPAA data in there, et cetera, et cetera. So in this case, we validated it's a developer VM, and we see there's financial data in there. So one of the policies that we look for is, we say a lower environment, meaning dev test, is not supposed to have production financial data or production PII information. So that's what the risk assessment will flag and give you the opportunity to sort of, let's say, implement the remediation step. Hold on. Here we go. Then we can go a step deeper as well. So the idea is we can look inside of the data asset, in this case a virtual machine, and then you can sort of quickly pinpoint where most of that sensitive information is located. Let's say, for example, an HR folder. There's a bunch of employee records here. Happens to be a PDF file. So here you can see the details of that exact piece of information, including if you're using things like Microsoft Purview for MIP labeling. We can validate that those MIP labels are there, and then help you implement labels if they're not applied, or if your data is mislabeled, let's say. All right. The other thing we can map out is how to do identities map to data. So what we'll do is we'll integrate with your IAM system. In this demo, it's based on AWS Control Tower, but so let's say it's Active Directory data in there. We map out users. So for example, here we have a user called Matthew Johnson. What we'll understand is these are the groups and potentially cloud roles that are associated or assigned to this Matthew Johnson. We'll calculate the effective permissions based on the assigned permissions, and then we'll show you visually as well what that identity has access to. So in this case, Matthew Johnson, who happens to be a QA engineer, seems to have very broad-based permissions across all of this sensitive data on the back end. So you'll put this in a ticket, you push this to the identity team, and they'll then have capabilities to right-size this access. Final quick thing is this anomaly detection concept, so data threat alerts, or DDR. So the idea here is that we'll monitor activity by integrating with logging services on the back end. And then just as a quick example here, we have sensitive data downloaded to a desktop. So you've implemented a policy that says that's not allowed. So we've detected this. In this case, we'll map it to the MITRE ATT&CK step, exfiltration. This is the data that's involved. This is the user that's involved, came out of an IP address in New York. This is the user application they're using, and this is the actual data that they've downloaded to their local desktop. How do we know this? From integrating with server logs, we can see the events, and we can see the actual API calls going to the backend and people downloading this sensitive data. So now you can respond to that and put in place whatever remediation makes sense. So that's sort of the front-end piece. So the second thing I want to quickly go over is, what about data destruction? So people are able to log in. Let's say they go for encryption instead of exfiltration. How do we sort of answer that issue? All right. So this is done through our Rubrik Security Cloud. So the concept of Rubrik is really, really simple, really, if we talk about data management. So it's all based around this idea of an SLA. So in an SLA, you define at a high level, what do I want to do with my data? So for example, if I pick vSphere virtual machines, it's basically an RTO-RPO policy where you say, okay, I want a backup twice a day, and I'm going to keep that for a week just to make it nice and simple. Do you also want to push that data somewhere else? So you can store it on the Rubrik side, but you can also archive it to another location. Could be the cloud, could be a NAS system that you have on-prem, could be another vendor system that you're sort of repurposing, whatever you want to do, really. So in this case, I'm going to push it to AWS, let's say, after a couple of days. Do you also want to replicate it? So maybe you want to push this data also to Dubai. You want to keep it there for, let's say, 3 days for quick recovery in Dubai. You say next. Do you also want to enable CDP on this? So by default, what we'll do is we'll integrate with VADP. We'll take a snapshot. That data comes to the Rubrik appliance. But the new data that you're creating between those VADP snapshots won't be on Rubrik, of course, right? We're not seeing that new I/O on our side. So a couple of years ago, we implemented CDP. So we're leveraging the VMware VIO API to get all of the I/O written to Rubrik as well. And then, let's say for half a day, you get that I/O landed on our system, and then you have the capability to play back to any point in time from a recovery perspective. Do you want to implement retention lock? So this is concept that I mentioned before. Now you need 2 people to agree if they want to change the 7 days to 1 day and get the data expired out of your system. Once you have set this up, you give it a name, and you create the SLA, and you're good to go. So now I have an SLA, and I can apply it to my workloads. So in this case, we have a bunch of data center workloads. Let's say it's VMware virtual machines. And maybe you want to do this broad-based. So you say, I'm going to implement it at the cluster level. And all of the new VMs that get created or appear in that cluster, they will inherit that SLA as a baseline protection policy. Or if you want to associate it with tags, that's fine as well. So you say, I want a bronze, silver, and gold one. There's maybe some internal chargeback associated with that. And then whatever tag you assign to that virtual machine or folder or host will pick up and will start to automatically protect it. So protecting is one thing. Now we can do recovery. That's cool. But of course, we also have these other data security capabilities on top. So with our data threat analytics, there's a couple of things we sort of continuously do. So we look for anomalous activity after each and every backup. Before storing it on our immutable file system, we'll run this job that looks for file system changes, creation of files that look suspicious, et cetera, all with the idea of allowing you to restore without reinfecting your network. So in this case, we have a bunch of anomalies. So we found some logbit associated ransomware, but we also have here ransomware that's based on the hypervisor level. So what we've seen since a couple of years is there's more and more malware actors targeting host virtual machines and encrypting those by sort of selectively encrypting files on the ESXi host itself, disabling your infrastructure. Sometimes combined with encrypting in-guest OSs as well. But it's very hard for traditional security tooling to detect this because there's typically not something that you don't have your EDR agent installed on your ESXi host or something like that. So what we do is we listen to that logging information coming from the ESXi host. That allows us to understand if something gets changed on that level. And then we're able to see things like, okay, for example, here we have a virtual machine. It's in critical condition. We couldn't back it up. And the reason we couldn't back it up is probably because, in this case, it's encrypted with ransomware. So do you want to restore it? You restore it back to a clean ESXi host. If it's a guest-based one, for example, here, I'll pick a random host. We've done our evaluation. So you have the event timeline here where we've done our detection of anomalous activity, file system changes. We've spotted even a ransom note that was published, in this case, on the desktop of that virtual machine. So the combination of that leads us to believe that this host has been infected with ransomware or encrypted, and now you want to restore it. So how do you know what you need to restore? So one way to do that is you say recover full snapshot. And then automatically what the system does is it will say, I'm going to recover the last healthy snapshot. So it looks back in this historical timeline and figures out, where am I not seeing this malware, where am I not seeing this encryption of data? And that's the snapshot he will pick for you to recover back into production. If you absolutely want to pick another one, maybe for forensic reasons or whatever, you're allowed to do that. But by default, we'll sort of force you not to shoot yourself in the foot, so to speak, right? So that's the goal. So that's one thing. And you can do this all manually. You can do it manually at scale. So you can essentially build groups called applications, restore those applications completely. So this could be multi-tiered virtual machines that make up an app and so on. But what we see in a lot of cases when there's actual ransomware activity, sort of stress levels get high, people are unsure of what to do, mistakes are made. So to sort of help you with that, we've created our AI bot called Ruby. So the way it works is it sort of continuously monitors for activity. So in this case, we found malicious file activity in an object, and then you can click on it. So now Ruby is saying, oh, we found this malicious file in this virtual machine, let's say. Let's investigate and build a response plan. So we want to get you back into production as quickly as possible. I'm going to make it easy on myself because I only have one hand. So I'm going to click on the prompts that he suggests. So in this case, he suggests, okay, tell me more about this ransomware. We'll go out. So we're doing some RAG and like integrating with external sources. Okay, this is related to this type of ransomware. And then you say, search for additional IOCs in the environment. Do you really want to do that? Yes. So the idea is that we've looked through your entire backup chain, and then we've seen, okay, this is the stuff that's been impacted, and this is the clean copy that we suggest you bring back. So we're trying to make this as user-friendly as possible, not because the goal is user-friendliness, but the goal is we do not want you to make mistakes at this, specifically stressful time in your life. So that's why we're trying to make that super easy. If you don't want to do it yourself, we also have the Rubrik ransomware recovery or response team. If you have a Rubrik license, you have access to the recovery and the response team. They've done this a bunch of times. So the idea is they will sit with you on the phone, over Zoom, however you prefer, and walk you through recovering this back into production using this technology, just to make it a bit more easy for you as well. All right, so I'm getting the cutoff sign. So with that, I'll leave you with it, so you can grab some lunch. I'll be around at our booth as well for the rest of the day. So if you want to ask some questions, more than welcome to do so. Thanks again for attending the session.